So in this question, we have two similar solid shapes, and we're told that the ratio of the surface area of shape A to the surface area of shape B is 3 to 4. And we can see that shape B obviously does look larger than shape A, so that would make sense. And we're told that the volume of shape B is 10 centimetres cubed. We're asked to work out the volume of shape A, given our answer correct to 3 significant figures. So here we have the ratio of the areas, the surface areas of the shape. And we want to work out the ratio between the volumes of the shape to work out the volume of A. So the way that we could do this is by working out kind of the linear relationship. So the scale factor of the lengths between the two shapes. So length multiplied by length is going to get us area. So if we want to work out the ratio between the lengths of the two shapes, what we can do is square root both sides of this ratio. So if we have the area, surface area ratio is 3 to 4, then we need to use a method to find the ratio or the scale factor of the lengths. So the length ratio here, length is going to be the square root of the area in this instance, so we can have root 3 to root 4. So root 3 to 2, because the square root of 4 is 2. Now, to get this in a bit more of a form that's a little bit easier to work with, we can divide both sides by root 3. So 1 to 2 divided by root 3, that gives us 1.1547, etc. Now, what we can do with this, we need to work out the ratio between the volumes. So the volume ratio here, now volume is going to be the length cubed. So we can now cube both sides of this ratio. So we can cube 1, which just gives us 1, and then if we cube 1.1547, or the exact value which I left in my calculator, that's going to give us 1.5396. And we can then take this value, and we know that we have 1, so this is going to be A to B, the volume ratio. We know that the volume of B is 10. So if we change this into a ratio x to 10, where x is the volume of shape A, then in order to work out what x is, we can simply take this 10 and divide it by 1.5396. And that's going to tell us the factor by which we must multiply the 1 of A by to get up to x. And because we're multiplying it by 1, this is just going to give us x. So the factor required to jump from this value to 10 is just given by 10 divided by that value, and that's going to be the same as what we multiply 1 by to get to x. And that value is going to be 6.495, etc. So just going back to this part here, to get from 1.5396 to 10, we're going to multiply by 6.495. So to get from 1 to x, we need to do the same thing to both sides, so multiply by 6.495. So the value of x here, which is the volume of A, is going to be 6.495, and it wants the answer correct to 3 significant figures, so 6.495 rounded to 3 significant figures, 1, 2, 3. To the right of the 9 is a 5, and that's greater than or equal to 5. So we're going to round the 9 up, however that takes us to 10, which then means we need to round the 4 up to a 5. So that just leaves us with 6.50 to 3 significant figures. Now the marks here, the first mark is awarded for the method to find the ratio between the lengths. So here. The second mark is for finding the ratio between the volumes. And then the third mark is for the correct final answer of 6.50, or an answer in the range of 6.49 to 6.53, just depending on how the answers have been rounded and kind of how the answers have been manipulated and rounded throughout the question. It might just give a slight fluctuation in possible answers at the end there.